Okay. I'm not sure if we're live or not. I've messed everything up. Everything looks different. It seems we have audio anyway. We seem to have some kind of video. If any sort of notification goes out of this, I really don't know. Well, it says we have a viewer anyway, but maybe that's just me. Regardless if everything's working. Hello, welcome to the very dead channel where we never post anything anymore. But maybe we'll get back into the game. So this, oh geez, I need to bring up the right thing. This is an old 24-volt battery charger. Oh boy, I'm missing all sorts of gear here. Haven't done this for a while, have I? Right, so this is an obscure old battery charger from God knows when. And stupid YouTube, shut up. Okay, this is an obscure old battery charger from God knows when, and it doesn't work properly. I've tried to power it up and it does kind of click and do things. It lights an LED when we press its button on the front. It doesn't put anything out, it puts a slight load on my power supply, which is off screen there. And that's about it. It says on its front panel there, it says question mark battery, or if we press the button, it says full battery. And it does sort of seem to try and start charging, but it never gets there. And anyone with an eye for old electronics will know that this thing is quite dated. It obviously hasn't seen any sort of renovation. Sarkybuggers in the chat. Hello there. David Blastron as well. Hello, it has been a while indeed. Anyway, we have a few suspicious components. We have a bunch of very old 230 volts main rectifier caps, and we have a couple of small electrolytic capacitors. These are the classic cheaper industrial Mark and branded ones, which always tend to go wrong. The jelly bean parts, so we have that. I've actually ordered these big capacitors so we can get them in there as well. I should probably dog those out before we started. David Blastron says good audio and video. Well, that's good. I've got a completely new audio setup. Once again, actually got a sound interface today, as opposed to just running it off a camera as we were before. But to make up for that positive change, the cable to my microphone's broken instead, so it's probably just making horrible noises right now. Anyway, I've got a big box of stuff here. I'm gonna see if I can dig out the big capacitors so we're ready to go when we need them. These are the wrong big capacitors. And these are the right big capacitors. Blur says, hello and all. Hello, Blur. Oh, Blur says sends a heart to everyone. Let's see. How do you do this? You do. That's sort of a heart to you as well, Blur. Anyway, we need to get underneath this board. It does look extremely simple, but I can see through the PCB that there's actually a bunch of surface-made components on the underside. If we get the microscope on there, you can maybe see some footprints through the PCB. David Blastron is asking for forgiveness for not watching the ads, and that's completely fine by me. I really don't give a toss. Your time is more valuable to you than the advertising revenue is to me. So these are our new caps. They should be normal snapping caps. I don't know if these are the 2 or 4 pole ones, but we'll make it work anyway. It's going to be fine. Now getting this thing apart properly is going to be a bit of a chore, since it's just sort of very integrated in its case. I'm not entirely sure how it's gonna come out, but I'm sure it will somehow. But we need to bring the multi screwdriver socket thing in. So we have a row of nuts and bolts holding a bunch of TO220s in there. Here we have this is connected through wires, so all this stuff I think can stay in, although we have an electrolytic cap there which I want to get rid of. I think that's the main rectifier cap on the secondary side, and it's a Marcon as well from God knows when. Here we have another nut in there. Do I actually have the right size thing pre-installed? It seems I do. David Blastrom says he's gonna join the Patreon once he gets a good income, and really I wouldn't suggest you do that. I haven't been able to put out much content at all. I don't deserve your money. Like, the Patreon should have been dead a long time ago. I haven't paid it any attention, and everyone just sort of keeps giving me money anyway, even though I produce one video every 2 months. And I feel sort of ashamed. I should just cancel the whole thing. But my wallet, you know, I'm a cheeky bastard. If people want to give me cash, I'm not going to say no. And clearly it does work, since being ashamed of not producing anything is part of why I'm here tonight. I was not going to do any sort of stream, but when I plugged this thing in and saw that it's actually not completely dead, I figured it might make some good content. And you guys deserve some entertainment for being subscribed. We are missing a bunch of cameras and stuff there. I've had to rip the entire streaming setup apart not too long ago, because I have like a giant touchscreen monitor thing here, which used to have a PC inside it, but the PC broke and the monitor stopped working, so I just had to completely destroy the entire bench here in order to get it out. It's like a 42-inch, 40-kilo hunk of steel, so it was quite the problem getting it out. Soggy Bugger asks, had much work this year? Yes, I have had more work than I can handle. This is part of it. This poor charger has been waiting for me for about a week now. I've had parts lying around, and a customer called and was like, hey, we need this charger this week, could you have it fixed? So we have to take care of it, and I just have mountains of things to go through. Maybe if we're lucky, I'm gonna be able to stream some of it, since I just reconstructed the entire streaming setup like just before starting this stream. Because it's... Oh, shut up, you stupid plastic thing. I just reconstructed the streaming setup after it's been just completely disassembled for so long. So this is a rectifier bridge that's bolted down. Oh, thank goodness it's got a screw on the bottom. We don't need to plier it out. I think that would be a posse driver 1. Oh yes, a posse driver 1. David Blastron says, and I quote, I do what I want with my money. You have a true dedication to Creative Commons, and that is more important to me than the irregularity in your content. Well, fair enough, thank you. I do like Creative Commons and public domain content. Do note that my content isn't strictly Creative Commons, it's CC0, so it's public domain. That's like Creative Commons extra strong, I suppose. Psychic says, it's all money in your pocket, don't knock it. I'm not knocking it, I just feel bad about not having time to do all the stuff I want. Like streaming and making videos is nice. The entire big solar system series is so far behind schedule because I just haven't had the time or energy to finish it. Mostly the energy, to be frank. Everyone always has time if they want to. But when you're just completely bogged down with doing stuff, it's not too inviting to get home and sit down and edit videos. It does take a fair amount of effort, and it's incredibly boring work. Just listening to yourself talk for hours on end, making minor corrections and putting little text things in when you say stuff wrong, or you say something you thought was true and then it turns out it wasn't true because you've had time to figure stuff out in the months it's been since you filmed all the stuff. I'm just walking around looking for a camera so we can take a picture for how this whole thing is wired up before we rip it apart too much. And I couldn't find anything better than the old 1000D. So we'll make do if it decides to work today. Yeah, how do you... This has an unstabilized lens and not a very good sensor. Not a very good anything at all, really, by today's standards. I think that's good enough. 200,000 plus shutter count, and it's on its second shutter. Second shutter, but still the original battery. This thing is amazing. I cut it up once, but yeah, battery from 2008, still working, a treat. We have a little, I believe this is a little tiny 12 volt reg here for powering the AMD CPU fan that's been cooling this thing. Oh, Devin Roberts just donated $5. Thank you very much. Asking, what's up, FF? Oh, too many things. If you've been here for 5 minutes, I've just been rambling on about how there's just too much work going on and I haven't had time to do anything other than work, eat and sleep, basically. This is part of one of many big projects I'm working on. This is the charger for, I think it's for backup diesel in, it would be a, what's the word, wind turbine. And I've been doing a shit ton of wind turbine work as well. Oh god, that made a horrible noise, I'm sure. But that's like a decently large wind turbine service company, local to me, and I do a lot of work for them. They take care of stuff all over southern Finland. And when we're dealing with these older turbines, there's just a lot of stuff you can't really get good support for anymore. And of course they could just shove a cheap C-Tech 24 volt charger instead of this thing in, but that's just going to require replacement every 5 years rather than every 35 years as this one seems to have lasted. So it's better, it's more economical for them to just have me fix it. And since I'm a bit of an altruist, I try not to charge ridiculous amounts of money for what I do either. I'm relatively cheap as far as industrial service goes. So this is probably just going to be barely more expensive than buying a new cheaper charger. Another bolt hiding in there. Come on, we can do this. Don't slip. So Devin, that's what's been going on. I've just been fixing shit. Here's a part for a giant plate printer for a printing press with the world's, we're talking $1 million equipment here, and we have like 10 Xena diodes soldered into it. Whoops, and it still exploded. Ah yeah, they also... Whoops. Whoopsie-doo-dah. Industrial stuff. David Boston says, lol, the cheap built-in sets. Did the extension separate itself from yours too? No. I don't think so. Nope, mine's completely complete. I am incredibly pedantic about my screwdriver sets. If a single thing in that thing goes missing, I will buy a new brand name one and put it in there. Just like that's my punishment for losing part of a kit. Something's keeping this thing together still. What's keeping this together? Abelaski is asking what's wrong with this thing. It's a battery charger. It is not charging the batteries. When it turns on, we do get front panel LEDs, but that's about it. It draws a bit of current, it puts a bit of a load on the battery. It never starts charging. I think what might be holding it down is thermal compound on the bottom of these TO220s. So I think I'm going to have to just rip them. Jonny Heinister says, I have no idea what you're doing. My friend just linked this to me. Well, we are repairing this 24-volt battery charger. If you are a nerdy electronicsy type of person, you might enjoy coming along for the ride. If you're just a normal person who has no idea what a 24-volt battery charger is, this might not be for you. Come on. Oh wow, there's actually a giant sill pad here. No wonder everything's stuck down. Hopefully we don't have to replace that. This board has guaranteed never been taken out before. And it really is stuck down quite good. Is the rectifier loose? The rectifier is loose. Crazy Logics 007 says howdy howdy. Hello there. 24-volt battery charger. Is that for truck batteries? Abeleski asks. No, this would be for diesel starter batteries on a for like backup system. So technically truck batteries, like, I mean, lead acid batteries, same thing. But this is for standby use, not for like charging a truck that someone's been cranking too much. God, this thing is really stuck down. I don't understand what it's stuck with. It must just be that there's so many screws going through the PCB. It's stuck down by friction, so we'll rip them out. I'm literally just struggling to get the board out of this thing. Oh yeah, and I need to take proper precautions and put some gloves on, because you always get so dirty on your fingers. Otherwise, that's just nasty and annoying. Step right up for exam. Jonny Heinister says, okay, well I have no clue, but I clicked like because you obviously deserve it for all this hard work. I'll even subscribe for no reason whatsoever. Well, thank you for padding my statistics, Jonny. I hope you'll find this entertaining enough anyway. Wow, Devin Roberts just compared me to Big Clive, jeez. I'm not that old yet. I'm Big Clive's younger version. Please God, no. I literally turned 28 today, so I suppose I'm not that far off. Jeez, this thing does not want to come out. But it's definitely stuck on these two screws. I can feel it just trying to break free. Oh, we still have power on. Whoops. yeah, it's coming loose now. I can feel the PCB moving when I turn these screws. So the board is just shoved super tight into the case. So Goodbye says, happy birthday, thank you very much. Devin Roberts says he meant to compare me to Big Clive content-wise. Okay, fair enough then. Although I think the average price of the stuff I work on is quite a bit different than his taste in devices. I think there might be like nuts soldered to the back of the board, because this just is super tightly held in and it is not coming out. Gah. That's not stuck to the board. Oh no, there's some kind of goopy glue on this. Ah, we've made a mess. Rose Electronics says, Big Clive's too big, YouTube can't fit him. Big Clive is indeed big in all sorts of ways. Man, I wonder if there's a Rule 34 on Big Clive. I'm going to Google that when I'm done. Alright, we're getting somewhere finally. We just have one more screw in the corner here. That's still keeping it down. That was the sound of a screw falling down. Oh, okay. Yeah, there are actually a couple of... There we go. That's what we want to see. This is... Oh god, this thing is really high tech. I thought this thing was simple. Oh man, that's too many ICs. I thought this thing was simple. So we want to desolder. Oh fuck, I haven't even turned on my desoldering station. And we need to desolder the inductors here, because else we're never going to be able to work on this board. Ah, jeez. This is not what I was expecting of this at all. So this is a very logic controlled thing. It's seen some work done there. This can be interesting. We're going to get it under the microscope in a moment. It could still be it's just got bad caps and we don't really need to care about any of this. We really just need to get the wires off, and this tip is not large enough to get any wires off. Let's get the chunk one on. A big Chungus 52D tip. 52D best tip. Creator Logics 007 asks, can you quickly recap what you have checked/found so far? Sure. I haven't done much. Most of the time we've been struggling to get the board out. But what I have found out is that this thing will sort of power on. It will get a logic supply. It will say battery question mark on the front panel. And if we press the status button, it will say battery fully charged. We can listen to it, and we can hear that it sort of goes chick, 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 making like pretty much the stereotypical bad capacitors in switching power supply sound. So I'm hoping it's just a couple of bad caps in this thing and nothing more. because it is somewhat alive. But it could also be much, much worse. It could be oh so much worse. Edward Hartman says, hang on. Edward Hartman says, is this thing a switcher made entirely from discrete logic? Yes, it does seem like that. They're all like op-amps, comparators, and 4,000 series logic. So it doesn't have to be too bad. We've also got the thermal infrared camera these days, so we can actually just... Often when logic circuits go bad, they will get warm. So we can just turn it on with a board flipped and see if any of these are going on fire. I don't have a good stock of SMD logic stuff though, so that's going to be a bit of a bother regardless. Marking these wires up so we get them back in the correct order. We'll just rip them off, then we can take the board under a microscope and have a look. Rose Electronics says, what does he say? Technicians work on technical stuff, but wizards work on electronics. Oh yes. These are fat wires. This thing puts out, I think it's 34 amps, so it does require fat wires. We'll suck the solder out of those holes while they're hot. Okay, that's just stuck to the fan wires there. And some other tiny thing. I think it's a voltage compensating wire. Voltage drop compensation wire. So let's have a look if I can manage to do that. I have no idea how well set up this microscope camera is, so you'll have to bear with me. It's not very good. So I saw that it had received some work over here. Jeez, that's ugly. Yuck. What? I had no idea what an LP29 is. LP29 51CM. That's obviously been screwed with in the past. Somewhat been probing around. We have some solder jointed stuff over here. This thing's soldered from above, so I don't think that's going to be an issue. That's just the regulator for the fan, I think. I'm just sort of looking for bad solder joints or obvious component damage. Stuff that looks discolored, broken. Cracked solder joint. This board is potted, which is super annoying. Yeah, but it's going to be the old-timey, waxy potting compound. Ew, that looks terrible. But it's fine. Yeah. Mega ohm resistors, that's yucky. These are double stacked resistors, there are two on top of each other. This thing has seen, it's probably factory modifications, a lot of this stuff. or guaranteed to be, because I don't think anyone's actually had this board out since it was installed. 300 volts. Good to know. Oh yeah, the capacitors are normal 2-pin units, so we can just swap those out, no problem. So these are going to be the switching transistors. Let's just beep those and make sure we don't have any shorts. I wouldn't expect there to be any, because it would probably be just smacking the fuse then, but it's worth checking. We have a gate drain source, standard FET pin out, so I'm just going to put the meter in the diode mode. Actually, let's see if we can do that. Give you guys a good view. So we want to have a diode between gate and drain. No, drain and source, sorry. If they are FETs, which they might not be, these might actually even be bipolar transistors, we should still have... There we go. They're slightly potted, that's why we're not making the connection. So yeah, that's fine. That's fine. That's fine. That's fine. And the last one. That's fine as well. And when testing FETs in like standard switch mode pacer pass, I have never ever in my experience seen a switching MOSFET where the diode has been fine if there's been any other sort of failure in the transistor. So if you get one diode drop across each of your MOSFETs, they're just fine. So the bad part is this thing actually seems pretty happy. Just looking it over with a microscope, I'm not seeing any obvious failures. No IC with a hole in it. No super broken solder joints. We have more double stacked resistors here, but the solder joints are fine. They don't look discolored. This thing really looks quite happy. So I think we'll bring out the strange ESR meter that I can't give out to anyone, and which you can't buy in a store anywhere. And we'll measure the electrolytics. I'm really praying that the electrolytic caps are just bad. Let's see if we can... Let's see if we can get audio. Let's find my stuff. Come on, don't be shy. So this is the ESR meter software thing that no one else has. Let's see the leads, that's fine. So we're going to be measuring the electrolytic caps. I don't have any camera set up for this view, so I'm sorry, you'll just have to trust me. So we have a 220 microfarad. Let's see what it says. Come on, make a connection. We are making a connection now. That's a 220 microfarad capacitor. That's not 220 microfarads, that's 12. I'm quite sure I got the pinout right, but I could still be wrong. No, that's definitely the capacitor. So the top number there is the equivalent series resistance. That should be much less than 1 ohm, like 0.1. We're seeing, you know, 100 times more than that, and the capacitance, the low number, should be 220 or above. And that's not right, so that's one bad cap. That's exactly what I want to see. We also have a 47 microfarad one here. Let's see if I can get the right pins for it. It will be these two. And that's our 47 microfarad capacitor. 20 ohms, 14 microfarads. So we have very bad capacitors. So hopefully that's the only issue. We're just going to swap all of them out. Let's measure the big ones as well. They're going to be 330 microfarads. I'm going to short them out. There might be a pop bang noise now, don't worry about it. No pop bang. They're discharged. So let's measure these. These are 330 microfarads. They're probably going to be fine. They're in parallel. So this would be a 660 microfarad cap. These are more or less okay. We're still going to replace them since I have them. But this is roughly what the other one should have looked like. Less than 1 ohm. So that's beautiful. We have exactly the failure mode I wanted to see. That makes me happy. That makes me a happy dog. Crazy Logics 007 says, I would check them out of circuit discharged. That's the thing about my magic ESR meter here. This thing is designed specifically for in-circuit testing. It doesn't charge the capacitor to more than about 0.2 volts. So the only part of a circuit that can affect the reading of this is parallel resistance across the capacitor, and the only way a parallel resistance can cause this meter to read wrong is by making it see more capacitance than is actually there. This meter will never, unless there's something very funny going on, read a capacitance that's too high, and it will never read an ESR that's too low. It just won't. During the 10 years I've had this meter, it has never ever done that. So I'm very confident in the measurements I'm getting here. Blur says, that's a Visual Studio program icon. Yeah, this entire meter is very beta test. It's like a project we did in school many years ago, and it turned into an amazing tool. Anyway, let's fetch a couple of new caps. 16 volts 47. Well, 16 volts 47 microfarads. Look at that. That's giant for that size. This thing is so old. At 35 220. 47 and 35 220. Two 2035 and a 47. And I promptly threw one of them away. So, just to give you guys an idea of how old this thing is, you see this capacitor here, that's 47 microfarads, 16 volts. This one is 47 microfarads, 50 volts. And it's the same size. That's just wow. Capacitors are so much smaller today than they used to be. Blur says caps can be temperamental with lower temps, correct? In relation to DisplayBoard in PC screens. Yeah, colder capacitors work worse than warm capacitors. When they're warm, they work better. So if something works better, if you go over it with a hot air gun, it might have bad caps. I'm gonna blow my nose, this is gonna be loud. Crazy Logics asks, nice, so what is your ESR meter that comes with the software? Well, it's a completely homemade thing that a friend of mine designed many years ago. It's supposed to be an open source design, but since like the code of the processor is using a few very proprietary libraries, we can't actually publish the design for it, and we've got a new one in the works, but it's some time away from being finished. But it's actually getting there. I've been promising an open source one of those for many years, but it's finally happening. I've got PCBs sitting around here that I need to assemble when I have time, and then we can start working on the code. Rector Magnificus asks, what are you going to use it for when it's fixed? This is the charger for a backup generator battery in a wind turbine on an island off the coast of Åland. So it's going to go right back there. It's worked so well in the past that the owners just want to keep using it. So we have negative. Let's just mark 8 for negatives on this thing so I don't forget. Negative. Negative. When I'm rambling on a stream, I'm sure to forget that. Blur says curved screen has been showing issues with the left side showing green artifacting thing, but the room is warm, it goes away back to normal. When it comes to curved screens, it's like in 90% of the cases, it's the panel that's bad. We have scrapped so many curved panels just because they can't make them properly. Do not buy curved panels, they break. I'm mongering this up by shoving other components around. My desoldering pump is actually broken. I can't change tips on it because it falls apart. So I'm stuck using a tip that's way too large for this board. But oh well, we make do. The conformal coating is being a bitch. Yeah, we can get one of those suck dry, but not the other. Like a really bad threesome. But I think we can just rip it out instead. Don't do that in a threesome. There we go. That's a 4 to 7 microfarad cap. There are no visible signs of failure on these. That's just because they're not that bad quality caps. They're just failed with age. We can sometimes see some signs of corrosion on the legs if we look underneath them, but the criteria I went for when inspecting this and deciding to suspect the capacitors is that it's an old Marcon. This particular brand of capacitor often fails silently. You don't see anything wrong with them. But they just dry out over time. They tend to sometimes leak around the legs, but this one hasn't. Ugh. This board is really not liking to get evacuated. Oh, for fuck's sake. The solder does not want to leave. Oh, that's because we have a big trace on the top side here, so we're not able to carry any heat into it. So we need to desolder it from the top. There we go. Now it's vacuated properly. So since there's a risk that this capacitor has been leaking, there might be corrosive crap left on the board. So I'm going to get my large bottle of alcohol and a Q-tip and give it a bit of a wipe, just to make sure there's no corrosive crap left there to corrode the board once we've put the new capacitor in. This stuff can be completely invisible to the naked eye, so this is always a smart move with stuff like this. And there's a bunch of crap on that. Right, that's the 47 mic. Where'd the new one go? There it is. So we'll just solder that in and make sure to put the little ceramic cap that we accidentally popped out of place back where it's supposed to be. The microscope generally just looks better in the small screen, so I'm just not going to make that big for you. And fan goes on. And we'll pop the capacitor back. And let's get some extra solder on there, then we'll grab the tweezers and do the rest. That's good enough. This capacitor is not really happy. It's sort of falling apart, but it's not critical. We don't need to mess with it any further. It's fine. But I did accidentally melt the solder on this resistor, so we're going to do that as well. There we go. Beautiful. Why is there's sticky substance on my snips? I don't know why, and I don't know what. Robert Case is staying up late, are we? Yeah, I got up at like 8 in the evening, 8:30 maybe, after sitting up like arguing with people online all night. Because hey, it's my birthday, I'm allowed to do that. So it's just early morning for me. So this is a 35 volt 220. I hope we have a right pin spacing on this, but we'll make do. And negative towards the power resistor. Edward Hartman says, a Q-tip with a drop of alcohol. What have you done with a real FF and his syringe of alcohol? I have a syringe, it's just empty, and I can't be bothered refilling it right now. So the big cap comes off as well. Ooh, this board is not liking to get evacuated at all. You can hear the desoldering pump just trying. No wait, I'm desoldering the wrong thing now. I'm desoldering the power resistor, not the capacitor. Crazy Logics and David Blastrom, thank you for the happy birthday wishes. I hate getting old, but oh well. So this is actually the capacitor. Put some fresh solder on there to make it a bit easier on the desoldering pump. And we move the leg around because that just makes the solder melt better. Taking care not to break any components off around it. This one is not coming off easy either. It's definitely still stuck on there. There's going to be fat traces on the top of the board. Oh jeez, this is annoying. We need to heat it and pull it out with the wider tip, because there's just too much thermal mass on the top of the board, so we're not managing to melt enough solder to actually desolder it properly. So we need to pull it out hot, like so, and now we can suck the holes dry. Because when the component leg is in the middle of a hole, it will want to form sweat joints along the edge of a leg, and you can't pull a component out if it's soldered in by sweat joints. It's just going to be ugly and rip the pass-through out of the board. Journey Jacob says, heat one leg at a time, wiggle it out, and then clean the holes. That's what you can't do on this particular board, because you can't get enough heat into the bottom side of the board to actually heat the top side of the board. There's just too much heat sinking on the top. It won't work. And so if you try to wiggle it, what you'll end up doing is just ripping the pass-through loose before you break the solder joint. It's not a huge deal, but it's ugly. It's much better to do it this way because you don't damage the board. And this is a lovely board because it's got dual pin spacing holes here, so even though this capacitor has the wrong pin spacing, it still fits. Lovely. Thank you, whoever designed this board. I will just solder that in. I forgot to turn on the fan. We'll just hold our breath. We need a lot of heat here actually, because we need to heat all the way through the board. Like so. And snip, snip. Journey Jacob says, crank up the temperature. That will not work, because the problem is not like the amount of temperature you have. The problem is the thermal resistance going through the board, through the thickness of the board. The via just does not have enough. The via has too high of a thermal resistance. The amount of degree C heating you get per centimeter of board or of the amount of degrees C you lose per centimeter of board is just too high. You can have like 500 degrees on one side and you'll still not be melting the solder on the other side because the heat sink on the other side of the board is just too hot. The problem is not the heat you have, but the problem is the heat that's being dissipated too far away from your soldering tip. Sometimes if you're working on an easy board, you can get away with a high temperature. That's why I always have my desoldering pump set to 400 or 420 degrees C. This thing is always pretty hot for that reason. So when it just doesn't work properly, I know that there's no point trying to add more heat. If I have a large track on the side I'm soldering on, that's a whole different deal. Then I can just take two soldering irons and add more heating, because then we don't have the bottlenecking our thermal input. But when you have the entire heatsink, the entire thermal load on the other side of the board, you can't add more heat. It's just not going to work. You're just going to be sit there heating forever, and the solder's just not going to melt. Anyway, let's have a look on the 220 microfarad cap. And this one, you can see, it's a bit more sad. It's got, obviously, some leaky stuff going on around one of the leads there. So this is not a happy camper. But from just looking at it otherwise, you can see it looks perfectly happy. But yeah, you can see if you have a mark on in a high hour device, it's going to be failed. These always fail. You can recognize mark-ons from the tip. That V-shaped vent, that's a mark-on. Kaha Turian asks, Ludwig, what do you think about the Carlson leakage tester? It's neat, but I haven't actually built or tested one. I don't have all that much use for it. It seems to work well though, I've seen the video. Kaha Turian? Kachaturian says Illinois capacitors also used to have that vent shape. That might be true. I haven't thought about it. I just know that the mark-ons, they're very common in European products. Use that, and it's a sure sign of failure. And DigiKey, they brag about that green packaging, but they still use plastic foil. Rather see a cardboard packaging for these, but oh well. Oh well. So we're just going to swap out the big caps as well. Negative side all pointing in that direction. Yeah, let's just get to it. These are snap-ins. You usually can't use a desoldering pump on them because the leads are so hard that you're just not going to be able to desolder them without just causing giant sweat joints. So we're going to preheat the board and then walk them out with the soldering iron. And I get to use my fancy thermal imaging smartphone. For this, let's hope there are no embarrassing hot furry sex DMs coming to me while we're doing this. We'll just bring this board up to a bit over 100 C. Oh wow, this is really heating up well. Oh wow, this is getting very hot. It's not got a giant thermal mass, this thing. Actually, we might be able to even just hot air these all together. We're already up at 170 C. Let's see if we can just hot air these without even bringing in the soldering iron. That would be easier. No, it's not going to happen. We're just going to popcorn the board. Shame. Admitted sake bugger? I thought that was common knowledge. So we'll just walk these out. This is always a bit ugly. Clono says, like, that's a really terrible thing now. What's a terrible thing now? Okay, number 1 out. And we'll suck the hole dry while we're at it. Since we already have heat in this part of the board, it's going to be easy. Saki says, I prefer them neatly trimmed. Hang on, let me just fetch something while we're on that subject. I got something just to be funny once. I should have it. Oh no, have I lost it? Oh no. Where is it? Ah, shit. I've lost my official streaming hat. I've lost my official hilarious pink streaming hat, damn it. I've been waiting to use it for so long, but now it's gone. Oh well, back to work. Screw it, I want to see if I can find my streaming hat, it's amazing. Just give me like 30 seconds, it should be around here somewhere. Where's the streaming hat? Where's the streaming hat? Where's the streaming hat? No. I'm not gonna find a streaming hat. Man, what a shame. Where were we? Sorry, bugger. Asks a big gift from Big Clive. No, it's something I bought on a ferry, just for fun. It's hilarious. I love it. I'm sure I'm going to find it. I'm sure you're going to see it soon enough. It might be out in a car actually, because I unironically wear like bright pink hats because it's just funny. Rector Magnificus asks, how many kilowatt hours can your new battery bank store, and how many does it save you annually? Spoiler alert for future videos, I've actually done a lot of testing on it, and its rated capacity would be something like 1200 amp hours. it's at about 85% capacity. So it's like 60 something kilowatt hours total storage. How much money it saves, I really don't know yet. I haven't had it long enough, but I should be able to run completely off grid for a large part of a year. But the problem is, it's just a bit difficult figuring out how to set everything up most efficiently. And of course we don't know how well it's going to perform in the long run, since it's all used batteries. But it should enable me to run completely off grid for many months out of a year, making all my car travel essentially free, since I drive an electric car. So it should save me quite a lot of money. Quite a lot indeed. It's so nice during the summer to just get in the car and know that, like, it's completely free to drive. You're just paying for the tires. Oh shit, we need to suck those holes while they're still hot. Clonoa asks, might as well ask what happened with this battery charger. I'm kind of late to the party. It just stopped working and then it came here. Before I started the stream, I tested it out slightly, and it was just making a switch mode that fails to start noises. And now we've found bad capacitors in it that we're replacing. And hopefully it's going to be working perfectly fine when we're done with that, because I do not want anything to be done in this section of it. I really do not want anything to be wrong in that section of it. But I don't think that's going to be the case. I think it's going to run just fine. We're optimistic. When you do this, you need to be very careful not to have any load on the capacitor you're bending out while you're heating the solder joint. You can only move it after all the solder has melted, or you run a huge risk of damaging the vias or damaging the tracks on the top of the board. And that makes no one happy. Out you come. Come on. Okay. Kachaturian asks, how do you like working upstairs? It's lovely. The basement is now a complete abandoned mess. But it's much nicer to have, like, temperature control and to not be working in a place that's incredibly freaking cold. I am, like, as a living organism, I am a very cold person. I'm always cold. Even in the middle of the summer, I can be cold. Even though everyone else is dying from heat stroke, I'll still be cold. When I drive a car, like, for 2/3 of the year, the heater is just cranked to max all the time. I just turn any climate control off and put the heater on max, and then I drive. So moving to a place where I actually have heating is, it's a dream come true. I love it here. I love it. It's lovely. Right here, new caps go in. Oh wow, it's looking a bit ugly. What's that discoloration? Has there been leakage from the cap? No. It must be some burnt flux from the factory. So in the new ones go. Pop. Pop. And pop. Snapping capacitors are so satisfying to install. So satisfying. And so satisfying to solder as well, because it just goes so well. Pornographic. It uses a lot of solder, but it's so worth it. Beautiful. Clono SS pop, the sound you don't want to hear when plugging it in. I don't think this thing is going to go pop. I think it's actually going to work just fine. I want to resolder this from the underside, by the way, because it's looking a bit dodgy. That's the controller for the fan, and it's soldered from the top, but the traces are on the bottom, and it hasn't been heated enough when they put it in. So we're relying on the vias to actually conduct electricity through the board, and that's a very bad idea. It often causes premature solder joint failure, because vias actually have a reasonably high resistance. It takes quite little current through a single via to cause a decent amount of heating. Let's ignore these terrible looking wires. Actually, let's not. There we go. I don't like the look of those guys, but oh well. So we've got all new capacitors in this thing, electrolytics anyway. Let's measure these guys just for the hell of it. So these are rated 385 volts, 330 microfarads. They're going to be close enough to that. Close enough. Where's my ESR meter? There's my ESR meter. Let's go to screen capture. Now let's find the right thing. And I reconnected that thing, so we need to re-zero it. It's actually zeroed fine enough, I think. Yeah, that's zeroed enough for me. Okay, 330 microfarads. Let's see what you have. 300, so it's 10% low, 250 milliamps. That's fine. It wouldn't have caused an issue. Let's do the second one. The second one. The second one. This one is completely open circuit. It's completely open circuit. So one of the big caps had actually failed. I don't recall who it was in chat. If I said they were going to be fine, they are very clearly not fine. And the third one, 290, 220 milliohms. So that was fine. But yeah, one of them has gone bad. This guy is not a happy camper. He is completely dead. That's a good thing we swapped them out. For now as is, better than failing short circuit. Better than failing short circuit indeed. Though actually sometimes when you have an open circuit failure on electrolytic caps, it causes so much ripple on the rest of the circuit that it causes further failures than it would have, than if it would have just short circuit and blown the fuse. So it's not always good, and we need to clean stuff up so we can't get around refilling the alcohol syringe. So we're just going to make a big mess. I can't do it on camera because I always spill alcohol everywhere. It's like a really bad night at a bar. Ah, fuck. The problem with these is they're basically impossible to fill. God. Like 10% of all the alcohol just goes on the floor. Blech. Look at that, yuck. Okay. There's alcohol underneath there. That's really bad, actually. It's gonna ruin my skin. Ah, damn it. Kachurian. For the love of God, man, how's your name supposed to be pronounced? Says, Big Clyde's trademark, purple pen, FFcossag's trademark alcohol syringe with red cap. Yes. So we're really in good shape to just put it back in the case, I think. I don't think we need to replace any of the sole pads. They're a bit ugly, but they should work. I'll work them off with a bit of alcohol to get any dust off it. That's not alcohol. That's alcohol. That's fine. That's fine. Oh yeah, we need to solder these in again as well. This is a very novel current sense transformer. They've just taken the wires as they go through the board and shoved them through an unpopulated EI core transformer. That's clever. Are you through the hole? No. And I'm putting these in the wrong way. That's where you're supposed to go. to suck a bit more solder out of this, I think. Hopefully that's going to go through. That's not going to go through, so we need to put some solder on and heat the board while we're shoving the wires through, or they're just not going to pass through. That's one. Oh, that's two. And we'll solder them properly. There we go. We also need to clean the rectifier on the board side of the old thermal compound. Johnny Jacob says, "Is it the middle of the night there too? I need to see if this works before I go to sleep." It is the middle of the night, but no time like the night time. Let's also resolder this big thing, because big heavy things like to fall off PCBs. And this thing seems very big and important, and it's definitely in series with the mains. We also have a screw terminal over here, which I do not trust. Screw terminals also love to just fall off. It's always a good idea to resolder them if you have a chance. Okay, I think the rest of this is going to be fine. We have the voltage thing that needs to go like so. It's going to be annoying to get in after everything's mounted. Mains input wiring. Mains input wiring probably goes best above all this other stuff. Getting the board in is going to be about as annoying as it was getting it out. That's one mains lead. Okay, we need to bolt down one of those before we do the other. Bendy. This is terrible for wiring. We need to throw our screwdriver to hell. We need to cut the zip tie there. We're not going to be able to reinstall this. I think that's going to work better. There we go. Johnny Jacob says, thermal paste on the bridge. Yes, we're getting there. I don't want to put the thermal paste on before I'm done messing with this, because it's just going to go everywhere. And while it's nice to be covered with white stuff sometimes, right now is not the time for that. we'll use out the pre, and there we get to a proper thick white stuff. Better. These cheap thermal compounds are, they always just turn to crap. Like the first few drops that come out, it's just translucent oil, basically. It doesn't do you any good. You can see it's just seeping into the paper there, making a complete mess. Now that should be all the thermal paste we need though. Do we really? I feel like we should have some more standoffs around here, but I'm not seeing any. I feel like we're missing. Oh no, they're just relying on some other stuff to get that done, I think. I hope. I really don't think we've lost any standoffs. We have not lost any standoffs. Oh boy, this is going to be incredibly annoying to get in. We need to get the LEDs into their respective holes first, I think. The mob is just getting caught over there. Now the board goes underneath a bunch of stuff. This is going to be a mess. Oh, this is going to be such a mess. How the hell is this supposed to happen? Like that, maybe? Now I've got thermal paste all over myself. There we go. It's whining and screaming and begging for mercy. Why are you not wanting to go down? What are you stuck on? There we go. It's in. We just made a minor mess. Saki Bugger asks, did you put the PTC back in? Yes, we did. Jonah Jacobs says, I have the same frustration with a cheap paste too. I find pulling air into the syringe and move a plunger in and out mixes it back up nicely. What I usually do is I just get 2 of these. I pull the plunger out of one, I empty another into the syringe, and I take a piece of wire and just monger it around and mix it up properly before I start using them. So this is actually a double-sized syringe. And the empty one, of course, turns into this. Some guy with a weird Russian name, I think, says, "We are Borg. We come from deep space to get this battery charger. Put your hands in the air. Your race will be assimilated. Or just get us your charger and we'll leave." No. I'm not giving anyone any chargers. I'm not a charity. Okay, so we need to bolt the TO220s down so they don't go on fire. We need to bolt this guy down so it doesn't go on fire. That was a big brown thing. Big, long, hard brown thing holding these down. Like so. And a few washers and bolts. We also need to bolt the fan controller transistor thing there down because I think that gets hot. And we don't want to break anything unless we really have to. Kachaturian says busbar. I wouldn't call this a busbar because it's not conductive, it's just like Bakelite. I think it's actually Bakelite. Or some weird like plywood concoction. It actually looks like construction plywood. Superbrain AK says no shmoo on the MOSFETs. No, because they have a sill pad. I clean the sill pad, it's fine. This thing like clearly doesn't dissipate too much heat because it doesn't even have a heat sink. It's just relying on air flowing over the aluminium case. I need my green nutty bolty holdy thing. Stupid microscope, go away. We don't want you. Click. 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 Clonoa says, the microscope will remember that. I'm free to slap my microscope all I want. It doesn't get a say, it has no rights. And now we bolt this transistory type thing down. For when you're too lazy to lift the board and use a screwdriver, you just twitch. That should be good enough. It's not rotated too badly. Oh fuck, we still have that cap to get rid of, but oh, how the hell are we going to do that properly? Oh jeez, that's going to be so annoying. Like, there's capacitor underneath all this mains wiring stuff. I'll have to think about that while we give it a test. That's not going to be the main failure mode, do we? Oh yeah, we'd still have the camera. So, I don't think this thing needs to be bolted down. That looks like a ground lug, so we do want to put that down. No, that's not going to work. Let's try it anyway. It did not work. Damn it. this is annoying. On you go. There we go. That's grinding enough for a test run. Oh, we still need more grinding there. Okay, and we need to bolt the rectifier down. We're just going to be installing all the bolts for this test. It seems there's like one left. But I'm going to be a rebel and not put the last one in before we know it works. Exciting screwing action. You just keep screwing until the white shmoo comes out of the sides. Ah, there we go. I think we're ready for a test. So we have the world's safest mains hookup right here. This is absolutely fine. And we have our 8-bit leads going to the power supply here. All these battery chargers always need to have an 8-bit voltage present to sense the batteries there before they put anything out, or they just never turn on. That's fine. Let's get the clamps. Safety interlock off. Hook that up. And we'll turn our battery on. So it hasn't gone on fire yet. It's not drawing any power. And mains on in 3, 2, 1. And I did not turn on the safety interlock. Safety interlock on. 3, 2, 1. Click. Fan noise. We have fan spin, and you can't see it, but we have 26 volts on the output. We have fan spin. Varauksen keskeytys says battery full. Because it didn't see any current drawn. And if we probe that, you can see 27.6 volts. That's a perfectly fine float voltage. In a moment it's probably going to turn off again. Or maybe not. But we should be able to take like a car headlight, that's conveniently lying in the trash can, and shove it across the output leads, and it shouldn't die. We'll clamp onto like random leads. There's probably something broken in this lamp. It's been replaced for a reason. The power supply that's acting battery is set to 100 milliamps, so if this lights, it's 100% powered by the charger. And it just shut off because the voltage is dropping too low. Come on. I think we need to give it a bit of a boost because the impedance in this lamp is just so low. So we'll give the power supply chance to warm it up for us. Come on, you can do it. The charge is just saying battery disconnected. I need more current. Ah yeah, this is a 24 volt charger, so the 12 volt light bulb is of course not going to be very happy. Let's take the other light bulb that's conveniently lying in the trash and put it in series. Oh no, that's not going to work because this one has a hole in it. I've got my dummy load up here, so we can just use the dummy load instead. Dummy load does whatever a dummy load does. I'm just like getting a long lead set up for it. Let's say it can do 8 ohms without going on fire. David Blastron says, lol, he remembered it was a 12 volt lamp. FF, I want the credit. You get the credit, Mr. 12 volt lamp, sir. I just replaced this in the van the other day. One of them went dark. Right, so now we have 8 ohms in some leads coming like here somewhere. Where are they? This is where we have 12 volts. No, 8 ohms. So let's do that instead. We need to remember that there's 230 volts on isolated mains there. I was not paying attention to that, and that's very bad. I need to be reprimanded for that. I could have killed myself. I still can't kill myself because I'm fucking with it. Okay, take 2. That's better. It's actually putting out current now. We have our load connected. Still have output voltage. The power supply is not supplying anything. It's drawing 127 watts from the power grid. Let's swap it to 4 ohms and see what happens. 4 ohms, it's drawing 220 watts. This is completely fine. This is completely fine. This is a successful repair. I'm happy with that. Let's do a quick calculation, see how much current we're putting out. I don't have my clamp meter. So let's say it's 75% efficient. So we have 220 watts times 0.75. That's 165 watts out. Divided by 27.6 equals 6 amps. So it has 6 amps. It's working fine. We just need to do the final mechanical assembly and replace this stupid cap, and then we're done. Let's see, 35 volts, 1 phase and mic. We should have something suitable. 25 volts. I'm quite sure I have 35 volts 1 phase and around here somewhere. They're just so large, I can't easily find them. 25 volts. 35 volts. 35 volts, 1000 microfarad. Beautiful. So I think, since I have nice long thin ones, we can just cut the old cap out and put the new one like so, because we have a fair bit of height to work with. Lovely. I got really worried when we got the board out and I saw that jungle of 4,000 series logic. It would have been so annoying if something was dead there. But nothing was dead there. It was just nice and happy. Let's put this final board mate in before I forget. David Blastron says he wasn't paying attention. He wants a recap of what's going on with a stupid cap. If there's a capacitor down here that hasn't been replaced yet and we're just putting a new one in there. I'm just going to cut the old one out and just tack another one on. Because when I do these sorts of jobs, like I'm not doing this to just get this thing running. I want it to be a nice, reliable product when I'm done with it. The reason we're doing this work is because this product, this charger, has an incredibly good reliability track record, and it's going to be much more reliable than something you buy from the store to do the same job, something new, for the same money you put on repairing it. Like, basically all the cheap industrial chargers you get aren't particularly reliable, and since replacing one of these is a pretty major project, since you have to go to the site which is remote as all hell, you really don't want something untrusted in there. Kachaturian asks, any video about your new electric car in the near future? I actually have a bunch of stuff filmed about that, but I haven't had time to edit it or anything. I've done a bunch of work on it and all sorts of things, but I just haven't had time to put the videos together. It's my bad. If you're curious, it's just a Nissan ENV 200, like an electric van. It's pretty cheap and standard. How the hell do we... Oh no, they've soldered the stupid sense wires to the capacitor leads. Ah, this just got annoying. And all of this is soldered. This cap is basically impossible to get out. I guess we're just gonna like snip one of the legs and leave it be there. Like if I get this and shove it in there, I think I can just destroy one of the legs. And bendy, bendy, rip and tear. Maybe I can actually snip that now that I ripped it out. Yes, I can. Oh no, there's a piece of metal just going somewhere in there. It went somewhere, I'm sure it'll shake out sooner or later. Ah, the goo. I don't want the shmoo to be released. that lead a little bit more. No, I just want to rip it out actually. Rip and tear. Destructive repair. There we go. One capacitor lead destroyed. The only reason I'm just not getting that capacitor out is because it's impossible. It's still hooked up in one lead and it's not going to be... it's not going to have any voltage across it, so it's not going to fail. It's not going to matter, we're just going to solder this like on there. And everything's going to be fine. When you're doing high reliability things, it's important to bend your capacitor leads properly. Never bend them right of a case. Always grab something and bend like a millimeter out. And we'll just like cut the leads to a reasonable length. Sam B is asking, Snip, how is the solar setup been going since you got it mostly done? It's actually completely done by now. I just haven't edited the videos. It's working very well actually. It's all in service. It's not doing a lot since we don't get sun at this time of year in this country. But during the later half of the summer, it was performing well. The inverter is wonky and terrible, but it's working. And it's producing roughly as much as it was planned to, although there's some drama going on with, or there was some drama going on with the solar panels. You're going to find out when I get around to editing one of the videos. But so the final output ended up being a bit different than was originally planned. So I'm just trying to solder to a giant copper bus bar right now. It's going to take a while. There we go. Let's put a bit of flux on this component leg so it actually has a chance to get soldered properly. But yeah, I ran mostly off-grid for most of the late summer. Soldering giant copper bus bar. Soldering giant copper bus bar. There we go. One lead down, one to go. Takes so long to heat giant copper bus bars. There we go. And I managed to heat with giant copper bus bar, but not for capacitor lead. There we go. That's actually stuck down now. Beautiful. Let's get rid of a giant blob of solder that actually accidentally fell off there. Oh no, it went flying. I think it went under the board. Damn it. So gobble-gully on that capacitor and it's going to be happy and fine. Oh. These stupid tips never work on these. They never ever work. You always just have to use the cap and a toothpick to get stuff out, so we'll just do it like that. Oh, that's gonna be reasonably stuck down. I don't think this thing sees any mechanical stress. I think it's bolted to like something that's sitting on concrete, so it's not. It doesn't need to be super mechanically strong. I just don't want it hanging by its lead. That causes failure. I don't like having that other capacitor just lying in there, but oh well. It is what it is, and we really can't get it out. This one's the right way around. Let's give this thing one last test before we bolt it back together. Let's not have a bunch of metal stuff and a 230 volt hookup. We need to disconnect with dummy load. We have this stuff safe enough. We enable the battery and make sure the dummy load stays disconnected. Now we enable the battery and 230 volts on. And it's charging. And battery on. And we still have, and load on, so we're putting out, and we'll still put out at 4 ohms. Yes, it will. Beautiful. This thing is working just fine. It turns itself off if you press the battery check button, which is supposed to be smart. All we need to do is bolt this back together, and it's going to be fine. It's just a question of putting back 1 million screws now, and we're going to be in good shape. Oh yeah, we have one mystery screw left. I think I know where it's supposed to go. I think it goes right here. Oh, we have another one that's undone for some reason, and it's stuck in the case. Oh yeah, and I'm forgetting to bolt the inductors in. Whoops. Though that wouldn't be the first time. When I got it, the inductors were not even installed. I have no idea what this stuff is, but we're just going to ignore it. We're just going to pretend it doesn't matter that they're covered in like extremely sticky brown goo. I'm sure it's by design. Ah, this is beautiful. I'm going to be able to deliver this thing tomorrow. Today, in a few hours. Oh, Jesus Christ, it's 5 in the morning already. Jeez. What the hell? I was not expecting this to take so long. When the hell did it get so late? Man. Oh, man. This is definitely proper screwdriver technique. We don't want to overdo these actually. You can sometimes crush inductors. Something like that. Yeah, that's fine. We don't want to crush them. Now there's one more screw to put in. Now that's in that hole. That's bolted down. These are all fine. That one's fine. That one's fine. That one's fine. This one's loose. There we go. One million small screws, and then we're done. These are posse too. So to recap, what we've done here is among the most basic electronics repairs you can do. We just took something out, we tried to turn it on. Well, you guys actually didn't see that, but you'll have to take my word for it. We heard that it made sad switch mode power supply noises by going chick, 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 and not putting anything out. Then we replaced the capacitors and it started working with zero brain power involved. And now it's going to go on to live a long, happy life, charging batteries in the middle of the sea somewhere. For eons to come. Stupid stainless thing stick on there. No, don't go flying. Oh, this is a different screw. This is a Phillips. No wonder it's not working. There we go. Ah, the top case as well. Yuck. Dust. Superbrain 8K says, nice, this is getting better than Diode Gone Wild's SMPS APFC delete video. I would not want to try and do an active PFC delete. That sounds like a bad time. Because when you have active PFC, I would imagine the rest of the device is built around having a fairly tightly regulated DC rail to run off of, so deleting that and making it unregulated is gonna cause problems. Daniel Malik says, there's there's a hole in glove, dear Lisa, dear Lisa. If that's a reference to something, it's over my head. And we have a lovely mix of Phillips and posi drives. That's terrible. Phillips, Phillips. Done. Beautiful. It works. Let's just power it on one last time just so you can get to see the LEDs light up. We can't use the load for that, but it's fine. This is not going anywhere. Safety interlock on. So now it says no battery. Turn the battery on. It's charging. And if we do that, it thinks the battery is full because it's reasonably full. If we turn the voltage up slightly, I guess it's just going to keep charging forever. Beautiful. Absolutely beautiful. It works. It works just fine. So I'm gonna have to thank you all for watching. How long have we been going? I have no idea because I don't understand YouTube. About 2 hours it seems. 2.5. And we're gonna end the stream now. So